one is just for those of you that do not know how to paraphrase or look for key phrases. I sort of put the important things in italics just to try to like help some of you figure out how to shorten stuff down, because there are so many different types of rocks that we're going to be going over today. If you try to write down every single word that's in the vocab, then we're not going to make it. And we're only talking about a few specific types. We can't go all the different hundreds of types of sedimentary rocks today. The ones that are normally the ones that are in classification kits, which I remembered to bring my book. We don't have all the samples that are supposed to be in that box. So once again, there's lots and lots and lots of pictures. Before we go into this with the opener, let me double check grades and let my computer decide that it's going to work for me. Okay, so the one from yesterday, which is open, but the one from yesterday, I'm missing one from Otis and the opener, the assignment from Caitlin, I don't think is online, from Eastside, the assignment, both from Erica, both from Dylan, and then the assignment from Colton. That was the one that was yesterday's. Also, if I sent you that email to do the test, yes, some of you have done them. I checked them. If you already did the test, then it should be in the grade book. They just reopened the grade book. I couldn't fix it until this morning. So it is almost 2021. All right, so of course, I don't know if that's email or if that's, okay. For this opener, that we've been talking about, that's all kinds of staticky. I think I shocked myself like 50 times yesterday with Florida. I'm afraid to touch stuff now. There are 4 processes in making a sedimentary rock. Okay.
Rock tumbler.
Actually have a rock tumbler at home. No, you an apple? Awesome. Okay, so what is the first part? There's 4 parts in creating a sedimentary rock. What has to happen first? No, before erosion. Weathering, okay, and then the erosion takes it somewhere. Okay, and then it obviously it deposits, okay, it settles. What happens after it well, actually, I guess technically deposition would be the next part. But what would happen next? It compacts and then it cements, okay, which is the 2 parts in what we call lithification, making a rock. So lithification, lith means stone, turning it into stone. That is what that translates to. I was going through some of my my ARD paperwork, and one of the mods that I read on a couple is, I can't remember how it was worked, basically make the vocabulary easier, and I was like, well, there's not much I can do with Latin, except try to explain to you what the parts mean. And so some of my students really like that graphic organizer, that flow chart. Some of you don't need those. And we'll have another one of those with the metamorphic, just in case that actually helps you. But we are going to talk about sedimentary rocks. Now, these first couple slides you actually should know because we talked about it before. Okay, lithification is when your sediment, okay, the dirt, that whatever that is the process of changing it from the loose, smaller particles into stone. So compaction is them pressing together. And then, now some rocks go directly from compaction. Some of them, they're very, very fine particles. So silt and mud, they can go directly to their stone, which is called silt stone and mudstone. Okay, some of them though, they need to be glued together. If the particles are too big, yes, they're going to compact, but after that, they have to be glued together. So the water brings in the smaller materials. We talked about these words yesterday, so it's more of like a refresher. Particles get brought in by water, the water gets pushed out, and then those finer particles that were brought in, it literally glues them together. And the ones that I have up here, and I realized, I looked up because I couldn't remember how to pronounce it, but this conglomerate and this is pronounced breccia, with two C's is a ch sound in Italian. I don't speak Italian, so they're done the same way. The big particles, they're glued together with smaller, whatever it was that went in between the pores. But the big difference with conglomerate is they've got rounded rocks, okay, and with the breccia, they're not rounded. They have what's called angular. You can see the sides of the rock. They can if they're exposed, but you're not going to see, like, literally with the conglomerate, these little guys that are sticking out, I mean, they're not smooth, but they basically, this is from moving water. How river rock gets rounded, that's what conglomerate comes from. Breccia is different. And so these words should not be new. Oh, I need a copy of the notes, paste myself. We went over them a couple times now. And we have, and then this next slide is the three types that we talked about yesterday. Take both words mean the same thing. Plastic or detrital are rocks that come from other weathered rocks. Okay, so sandstone. We haven't been talking about shale yet. We will talk about shale. Shale is a very, very, very common rock where you find fossils. The carbon residue fossils. Crystalline or chemical, water dissolves minerals, takes them somewhere, a lake, I don't know, a tidal pool, something. Then the water evaporates away, those chemicals recombine into something new, and then they form things like limestone and halite, dolomite. There's a couple others. Like I said, I can't go over every single type. But we talked rock salt. Its fancy name is halite. I had multiple people ask to lick the rock. I think in this class somebody asked to lick the rock.
Each of us.
It's disgusting. You know how many students have touched those anyways?
No, I mean like pretty.
Oh.
I would keep that in my mouth.
It's going to dissolve. It's salt. If you ate that much halite, it would probably kill you.
Really? Oh man.
You know how much salt that
You gotta give me a big piece.
is? I have any. If you ate this much salt, you would probably die.
Nuh-uh.
What? Do you know how much
I'm
salt
gonna
this
make
is?
gumballs out of those things.
Sodium.
Like, you would probably have a heart attack.
I eat a lot of sugar as it is.
You do not want to get a kidney stone. Okay, so once again, and then the other type, the bioplastic, the organic material. I did have a piece of the fossil-rich limestone. This one, I didn't realize I did, but you can actually see the impressions of the shells. This is an organic type of limestone. This is the inorganic or the crystallized version of limestone. They're still more than 50% calcite, but this is one of the only type of rocks, one of the few types of rocks that can be two different classifications for sedimentary. I'm pretty sure I made that a test question next week. So once again, that's limestone. It can be both the chemical, which is the inorganic, or it can be with the fossils, which brings in the organic. What I just held up, that fossil-rich limestone, this coquina, it's another common term for it.
What is it?
Coquina. I don't.
That stands for cocaine.
No, it's not cocaine.
Yes,
Oh my gosh.
Maybe.
Coquilla.
No. No.
That's cocaine.
Oh,
I'm telling you, bro, it's cocaine.
I swear, the ways that things go in this class.
Got that pixie dust.
Stop it. My fifth period got off on a tangent about killing babies and eating them and turning them into lampshades, and I was like, how does your brain think that way? All right, so plastic rocks. We just talked about this, the weather, the erosion, the deposition, and then there are multiple parts to lithification, but we talked about those yesterday. So you have rocks that are exposed, okay, and then you have weathering that's occurring, whether it be rain, wind, ice, animals, acid rain, there's all different kinds of types. Then the erosion takes it somewhere else, normally by water and by wind. Those are the two major transport methods. And then you have everything that is deposited, and then it is lithified and is turned to stone. So these are your four processes, and yes, there are multiple parts for lithification, but that's the generic term of being turned into rock. Grain size. If they're extremely large, we call them boulders. And that is more than 256 millimeters. So you've got one that's, let's see, that would be 2 milli to centi is 25.6. I can't do math in my head anymore. There are, come on computer, or wake up phone, get my calculator. So 2.56, no, 25.6 divided by, there's 2.54 centimeters in an inch. Oops. 256, 25.6 divided by 2.54. So at least 10 inches, if we put it into what we understand. If it's below that, we call them puddles. I don't know if you've ever been to an older city, especially in the Northeast. They were cobblestone roads. I know Pennsylvania and Philadelphia still has one. I haven't been all over the Northeast. Pebbles will be smaller. Sand. Now, anything that's from sand up, these have to be cemented together. And anything that's below sand can directly be compacted. I know we don't think of as a sand grain as large, but when it comes to actually being able to be pressed into a rock, that's sort of the point where it's a little bit too large. Sandstone is cemented together. Siltstone and claystone, and mudstone for that matter, they are compacted together just with sheer pressure. There's a chart that I think I put on your, I did. I was nice and gave you this chart. There's a whole heck of a lot of information on there, so we don't have to write it all. And it also puts the symbols of what it looks like on cross sections. You don't have to try to draw them out. Okay, but silt is like what you think of as the dirt in a river, and then clay is even smaller. We have a lot of clay in this area. That's why we don't really build basements in this part of Texas. It's not that we're going to necessarily flood, but clay moves and it'll break your basement essentially. Yes, basically. Stop it. So transportation, water and wind, glaciers move a lot of stuff. Okay, so that would be your ice motion. But transportation is basically what's happening with erosion. It is moving your broken up bits of rock somewhere else.
Are they melting?
Or what melting?
Yeah.
I mean, they have some do.
Those are the good.
So, I mean,
I'm gonna build a house on
you want to build a house on a glacier?
it. Yes.
I don't think that would be a wise decision.
But I do.
It'd be a boathouse.
I would not recommend that. All right, so in the process of the erosion, okay, specifically with water, the rounding of the pebbles has to do with them being knocked up against each other as they're tumbling. And this does happen with sand too, okay, but rounding is just because of friction against other rocks, other things as they're moving from point A to point B. And as they go from one point to another, the faster it's moving, the larger particles can be moved. I don't know if you've ever seen like the Gold Rush shows where they have those sluice boxes.
Yes.
Okay, the big particles always come out first. And then down at the very, very, very end are the fine ones, and that's where they collect the gold, and sometimes there's like garnets and stuff that are in it. That's literally what this is showing. It's just not in a sluice box. This is naturally what happens in a river. So where your river's flowing faster, larger rocks can be moved. Where it's moving slower, your smaller particles will settle out. It's the natural version of what you see on those shows. I don't know if they're still making new episodes of that or not. I stopped watching those shows a long time ago.
Oh, yeah.
Mm-hmm. Kid's name was Parker, I think, and then his grandfather died. I was watching it when that happened. That was sad. And then I can't remember all the other people. There are people that went to like the Amazon thinking that would be a smart idea. Yeah, that didn't work out so well. So as the thing goes further along, and it also does depend on the speed of the water, that's going to help sort them out by particle size. And I don't know if you did watch those episodes, if the water was moving too fast, they literally blew the gold out the backside. It's not difficult math, but basically you calculate a formula. How long does your sluice box have to be with the speed of the water that's coming in? Or how much force are you putting behind when you're pumping the water into it? Yes, you use this.
Yeah, it's just so fun going
Yeah.
and rivers.
Yes, you can. Like literally can. You can. If you're in the right area. Yes, people do this.
I'm gonna go out and do it now.
Honestly, I think in some areas, like Colorado specifically, it's illegal to just go and pan for gold on your own. Honestly, I do.
You know, it's also illegal to collect drinking water.
In a lot of places, yes.
It's stupid.
Which is dumb. I do agree. I do agree. Well, it just depends on where you are. Deposition, like I said, we're going over a lot of these words again, just because these are probably the more from before Thanksgiving break, and y'all didn't study this class over the break, and no, you didn't. Deposition is when the sediment settles, and it comes to rest on the bottom of the riverbed or wherever. It could be that the chemicals are crystallizing back out. So they're coming together, which is what accumulation means. You accumulate, and they recrystallize. There are 5 different environments where we do have deposition of sediments. It's just depositing. That's what deposition means. The bottom of the ocean, deep in the ocean, not shallow, on the beach, in the deserts, which are both sand dunes, just one is coastal and one is not, within a river, channels just the body of the river, or at the bottom of the lake.
There's-
I'm sorry, it will heat back up. So this is it looks more like a delta to me, but this is a river. This is not a lake.
So, like, the Sahara Desert,
Mm-hmm.
isn't it the ocean?
Used to be at one point in time? Yes. A lot of areas that have desert used to have, our Earth is constantly changing. It's not like you're just gonna watch it happen because we don't live millions and millions of years. But we'll talk about like what they call Earth's changing surface, is that section of Earth space science. That should be after Christmas. Let me check my the thing that tells me what I'm supposed to teach. Yeah, Earth's changing surface will be after Christmas. The history of life. I'm gonna have to push plate tectonics. We'll start it next week, but I'm only gonna really have 2 days. That's not enough time to do all of plate tectonics. It's not. That's gonna have to carry over, and we'll have to finish that after Christmas break. And then we'll get into Earth's changing surface, and then we'll get into evolution or history of life. A lot of people don't like the E word, like, oh, this does not bother me what anybody's religious preferences are. It's, you have to talk about it like, 'cause things evolve, they do. Right, so lithification, where am I at? Preservation, this is how the dinosaur tracks. If you've ever seen pictures of them. So the dinosaur left an imprint, and that actually solidified. Something happened where there was no deposition, where that rock solidified. And that was possibly filled in with other sediment, which may have been washed away. If they're exposed, that is what happened. They were preserved in the sand or the mud, where the dinosaur was walking around. Lithification, once again, it's the second time you've seen it. It's the process of turning to stone, to rock. Oh, I should have changed that to SR. Let me change these to SR. Because I have people that seriously will write every single word that I say. I'm trying to help them. I'm sorry, I just banged my desk. All right, so sedimentary rock, please use SR. I'm telling you guys, my 6th period, I think we still had 4 slides left. I was like, watch the YouTube.
We built our home on a road. We call it a mobile home.
A mobile home, if it was on a glacier, definitely would be moving. Not quickly. Glaciers don't move quickly. All right, so I showed you an image similar to the one that's down here yesterday. You have your rocks that settle, other things settle on top of them. It pushes them down. They start to be squeezed together. If there's enough space in between, in will come in silt normally. And then that actually works as the glue to cement them back together. So these last few slides, they basically were a recap of what we did yesterday. All right, breccia. I was pronouncing it incorrectly yesterday. I had to look it up. Like I said, I do not speak Latin. Breccia and conglomerate are very coarse-grained. They don't have a fancy phrase like we did with igneous, as far as the phenolitic and the aphonetic. They don't use those. Breccia is angular pieces. Means you can see edges. Conglomerate is rounded big pieces. You need to know this specifically for your test next week. That the conglomerate, like if you feel them, they're smooth pebbles. They're small, but they're not sharp. Whereas if the breccia was exposed, not that it would necessarily slice your finger off, but you can feel edges, which means it's angular. And sandstone is a medium-grained set. Oh, I need to change that to SR. Like I said, if I do not take your hat off, Alex. Oh, I forgot. Burn it. Watch it melt. Put sulfuric acid on it and watch it. No, what is it? Stop it. Oops, I just made a boo-boo.
I don't see any.
Hold on here.
Oh, never mind.
They're in there somewhere, I promise. All right. I'm changing it from sedimentary rock to SR because, like I said, I love my 6th period. They're great kids, but whew. All right, so I don't know if I put it on the image. Oh, I did. Ooh, did I seriously lose my image? 1, 2. Oh no, that's gray whack on there. Okay, so sandstone is the smallest particle that has to be cemented. That's because it's from sand. Anything that's smaller than that will be compacted. All right, so quartz sandstone. It is at least 90% quartz. I thought I had Arcos in here, but I'm not seeing it. I'm not seeing it at all. It's like somebody took the little stickers off the ones that they put in there. And I don't know. I forgot to take those home to analyze them. Arcos is mostly feldspar and quartz. I looked this up to make sure that was pronounced gray whack. It is. I was like, there's no way it's pronounced the way it looks, but it is. It is pronounced gray whack. This is found a lot of times at the bottom of lakes, just like limestone was. And yesterday we mentioned that that's why in the United States, most of our bedrock is limestone because we were a gigantic inland sea. The plains areas were a gigantic inland sea for forever.
For what?
An inland sea in the plains. That's why most of our bedrock in this country is limestone. Obviously the mountains are granite. That's what makes mountains, granite.
So like, you mean like water?
Yes.
Oh.
Yes. So like the desert out in Arizona, that was all an inland sea. You can find fish fossils in like every single desert ever on this continent. So that top one is quartz sandstone, this one is Arcos, and this one is gray whack. And that Arcos is supposed to be in here, but it's not in here. It's supposed to be in there though. Gray whack is not. There's a sandstone in there. Sandstone is. Quartz sandstone is this one. At least that's what it says is this one. I have to assume that they didn't pull the stickers off and change it. And then this one is regular sandstone. Regular sandstone can have all different colors in it. Like I said, if you've got those coasters that have the sort of orange and yellow stripy patterns, those are cut from sandstone. Shale. We frack shale. It's fracked here. It's what causes very, very, very minor earthquakes in this area. They basically blast the shale, they percuss it, and then they pull the oil out of it. And then those voids collapse and they cause minor earthquakes. My parents felt one in Keller like maybe 5 years ago. Just a little one, enough to sway the light over the kitchen table. But the thing about shale is it splits into layers. Now this type for shale, this type of cleavage is called fizzle. Shale, and I should have put this on here. You find fossils in shale a lot. And it looks like I did not add that on here. Now, not like the indention ones in the actual shells like you do in limestone, but those casts of plants. If you see like fern leaves, that happens a lot in shale. We crush up shale for what's called caliche, which is what they can do driveways with, not concrete, it's like crushed stone. And I know as a child with my grandmother's house when we were at Mimi's, that was one of the things that I would just start turning over shale and I would find those carbon residue fossils, those trace fossils all over the place. And if you notice, shale is going to be deposited somewhere where we have water. That's where it forms. Oh, I did add it on here. Many times it does have fossils, specifically trace fossils. Those are those imprints of delicate tissue. Siltstone, made from silt. It does not fizzle. It does not cleave in those flat lines the way that shale does. It looks like shale though. Claystone is made from compacted clay. It also doesn't split on those flat plains. Mudstone is made from mud. And these make very, very, very large rocky structures. This is siltstone, and that is claystone. I did not put one on mudstone up here. Mudstone has, it almost looks like the ripples on the, it almost looks like ripples on the beach, okay, but it does it this way up the rock. It has a very, very distinct pattern, and I found these 3 huge boxes of rocks back there, and I think they're supposed to be separated as igneous, metamorphic, and sedimentary, but once again, there aren't any keys in there, and I didn't find any that looks like mudstone. So mudstone sort of looks like this, but it's not all sharp angles. It's ripply looking, like like ripples on a pond. At least not all of the names of the rocks are Latin in this particular type. All right, so next type, chemical. Okay, so this is the type where the water dissolves minerals, takes them somewhere else. Those chemicals recombine into a different chemical format, and then when the water evaporates, they crystallize into a rock. A lot of them do have carbonates in them. Carbonate is a carbon, 3 oxygens, carries a -2 charge. Go back to chemistry. Like I said, I'm not turning this into an organic chemistry class, but that is what carbonate's formula is. Calcite is a type of carbonate, very, very, very common in limestone. And like I said, there's two different types that are up here. And I know this is a test question. Okay, so I think there's one more on here. The two types of limestone. This is one of the few that can be both chemical or crystalline, which is the regular limestone, or have organic parts, which is all the shells. The organic material came from the snails and the clams and all the other little marine life that was there. I mean, the shell doesn't die technically. The animal dies and the shell falls down into the silt. And once this stuff is crystallizing, it picks those shells up and it gets cemented in with them. Dolomite is another one. I don't have any dolomite in here. Or dolostone is another phrase for it. We've got the fossilized limestone here. We have, I'm not sure which one is which over here because I can't see crystals in the picture. It looks this one, actually it'd be easier for me to see it on the screen. This is fossilized. This is crystallized. So these are both the limestone, and then this one is going to be the dolomite over here. There's still all types of limestone. They still have huge amounts of calcite in them. There's a deviate of carbonate. We're gonna push it out. All right, shirt. What else is shirt from shirt? And then you go look up that pronunciation too. The first image that's going to be over there in that void is a picture of it. It's silicates. Silicates are also what make quartz. So it's not going to be clear crystalline type structure because we have actual sediment that's part of it. But it looks like almost like bricks. It's very, very blocky. The evaporates, this is how rock salt, halite, limestone. There's a bunch of them. I'm not going to have you learn 200 types of sedimentary rocks. Gypsum is another type. It said rock salt. The fancy term for it is halite. And I have lots and lots and lots of those. Very, very cubic cleavage when it naturally breaks. Obviously, if you shatter it, they're broken down into smaller pieces, but if you zoom into it, even with a salt grain, it has the same structure. That is its crystalline structure. Still need to do the bioplastics. And I need to show you this chart, which you have on your Canvas page. Okay, so, and then this one is just showing you a salt flat. There are companies that literally go to salt flats, which is why that's white. And it's not sand, it's salt. And they literally have machines that chew it up, they harvest it, they process it. A lot of times we add iodine to it, because otherwise we get not diseases, but deficiencies of iodine causes, I think it's goiter. Crush it up into smaller bits, package it, and sell it. Somebody asked me, how much is salt worth, like, per gram? I don't know. I don't, stop it.
Are you selling?
What is wrong with you?
Sell salt? I'm not a big ball.
You want to buy a bottle of salt. Now, I do not know what the price per gram is for salt. Honestly, I do not know. I'm not a salt miner. All right, bioplastic, or the organic things that came from living things. We talked about coal specifically. There are 4 types. There's the anthracite. That's the hard stuff. There's the bituminous, which is the softer charcoal. There's the subbituminous, and then there's the lignite. Those are the 4 major types. And it has to do with how much pressure was put on that peat, things like the bog, the peat, The more pressure, the more it was squeezed out, the harder the rock. The harder the rock, the slower it burns, which is why we use the anthracite, the hard coal from Pennsylvania, this stuff. This is what they use in coal engines, which we don't really use anymore because that's dirty fuel and we have EPA regulations and they're like, no, you can't use coal, but a lot of countries still do. Like China and India, because they don't have the same regulations that we do. Most coal engines, like trains, they have been completely and totally phased out. Now, they haven't necessarily dismantled those old trains. They're like on display, but they don't run them anymore. It's a very, very, very dirty fuel. Some people do. Okay, so the people that do use coal still, blacksmiths, they're still coal forges. It's a way to heat the iron, and then you got. So yeah, I mean there are still people that use coal. It's not like it's illegal to buy or anything like that. But as far as like mass producing energy, no. Right. They have been phased out. Now we use the softer coal as charcoal. So I mean it's not like we don't use it. The old coal engines, when they would go through tunnels, you did not want to be in the back of the train. Because if they ever got stuck, those people would all die.
Oh.
With those old coal engines. It did happen. You can't, I mean, you're breathing coal dust, like you die. So,
Really?
I don't want to say, we can take your cat.
Oh, okay. I was mad at somebody, I'll take their food.
So, well, I mean, we do, if you have a barbecue that uses charcoal as bar.
Like cold. Like, you put in the train.
Oh, well, now, but that type, that's what's used in forges. It's because it lasts so long.
But so if you like cook with coal in it, kill them and eat it, like toxic removal.
Well, you don't like put it in the coal to cook it. You put it on the, yeah, it's, now the smoke is what gives it a definite flavor, but it's not putting pieces of coal in the food.
Oh, I'm trying to.
Okay. Oil and natural gas, they're also organic. You have extra heat that basically changes it from coal to either the liquid, which is oil, okay, or the gaseous, the natural gas, which is essentially methane. Propane, methane, and butane. There's all different kinds. Butadiene is really bad. Huh? What time do we get out? 10 minutes. And so the last thing that I have on here, you have this chart. Okay, it puts the particle size on here. Okay, we talked about the plastics. We got the big ones. We got the medium size, and then we have the smaller ones. That these are the ones that are going to go through compaction. So clay will make shale, silt will make siltstone, sand makes sandstone, and then these are your larger ones, the glover, the breccia. In a cross-cutting, this is what you're going to see in that section. That is their map symbol for that layer of rock. And then the crystalline, you got your smallest crystals, which are halite, and then your largest crystals, which are dolomite. Dolomite makes dolostone. The gypsum makes rock gypsum. Once again, same thing, salt, halite. This is what their symbols look like. And then I keep, the bottom one is the organic. Go away, bar. Okay. You do need to know that your bioplastic are made from carbon. You need to know this. This is what coal, and if I move my cursor, the bottom right one, the darker one, you need to know that that represents coal. I guarantee you that will be a question because I've seen it repeatedly on these EOC tests that I'm pulling all these questions from. So you have this, okay, make a side note if you need to, that coal is that dark, the coal's black, y'all. It's that dark with the little wiggly lines in it. You definitely need to know that. Now let me freeze this and turn the light on. There isn't a side that goes with this guy. You did not keep it on from yesterday. And I've already mentioned this. It says on 76 and it says it's 69 on here. I don't understand my thermostat at all. Well, it wouldn't work at all if it was broken. Let me stop the recording and I need to